The other thing that you need to know in experimental research is the methods that are available to control a confounding variable. For example, if gender is a confounding variable in a research, so you believe that the difference between control group and experimental group happened because we had more boys in the experimental group, for example. So in this case, we want to see what ways are there that we can use to control gender. There are basically three ways. One is holding a variable constant. So in order to avoid the gender differences, we do our experiments only on boys. That's called holding variable constant. The other one is matching method. The matching method is a method in which for each boy in the experimental group we have a boy in control group, and for each girl in the control group we have a girl in experimental group. This way the number of boys and girls in experimental group and control group is the same, while we may still have more boys in both groups, okay, but the number is equal between experimental and control group. And finally, it's randomization, that we have like 100 people and we randomly divide them or assign them into control group and experimental group. This picture shows what I just said, that for example here we have gender hold constant. As you see, all the participants are female. This is matched. For each male we have male here, for each female we have a female here, but as you see, still the number of female in both groups is higher than the number of male. And finally, we can do randomization. Randomly we divide them into two groups, but still we may have more female than male in one group. Okay, so the question might be, which one is better? The answer is generally randomization is better, because in randomization you not only control the gender variable, but also you can control IQ, parental income, parental education, so many other things. It's randomly distributed. But if gender is your only concern, or if you want to make sure 100% gender is not an issue, then holding a variable constant is a better method, because even if you do randomization, you may not be able to say 100% gender is not an issue. So any confounding variable that you want to control 100%, use holding that variable constant. But if you're not only worried about one variable and you want to take care of many confounding variables, which is most of the time our main concern, we use randomization. Okay, now we switch to research design, which is similar to true experimental research, but it's not exactly like that. It's called quasi-experimental design. Quasi-experimental design, like I said, it's similar to experimental research, except that we have some confounding variables because we don't have random assignment. So if you don't have random assignment, no matter what you do, your research is not a true experimental research. Another kind of research that people do, and sometimes they claim that it's an experimental research, is called ex post facto research, which actually they compare pre-existing groups. So if you, for example, do a research, you compare boys and girls, that's not experimental research. Or if you compare graduates of College of Engineering with the graduates of College of Education, that's not experimental research, because you are just using intact or pre-existing groups, and you cannot claim any kind of cause and effect relationship in these examples. So far, I've been talking about two groups: control group and experimental group. But sometimes we need to have two control groups or two experimental groups. And also sometimes, besides the no treatment group or the control group, we have a placebo group. Placebo group or placebo control group is the group that they don't get the treatment, but they think they're getting it. So they are under the impression that they are getting the treatment. Most of the examples in placebo effect is in medical science, that one group receives the medicine, the other group doesn't receive the medicine, and there is also a third group that they think they got the medicine, but they did actually received a placebo. And another factor in experimental research is manipulation check. Let me explain this by an example. A few years ago, I had a student who wanted to do a research on podcasts, and he wanted to compare teachers who use podcasts and those who don't, and see podcasts make a difference in students' learning. So I asked him, what if you do your research and then you don't see a difference? And he said, okay, if I don't see a difference, that means the podcasts were not helpful. And then I said, you got to do manipulation check, because the instructor may publish or post their podcast, but students never download this or never listen to it, or they don't go through the whole thing. So you need to have a manipulation check to see if your treatment actually was perceived by the students or by the participants. And finally, we have two versions of experimental research that are simulation and field studies. And usually we do this because we want to increase the external validity of the results. If you remember, at the beginning of this presentation, I said a big complaint about experimental research is that because we control so many variables, it's not real, it's artificial. So the researchers have used simulation and field study to increase the external validity of their research. The best example I've seen of a simulation is the research that was done in Stanford University, and it's a very famous research that they actually randomly assigned the students to two groups of guards and inmates, and they created like a prison or jail in the basement of the psychology department, and everybody was playing a role of guard or inmates, and after a few weeks their behavior started to change. There is a link here that if you click on this link, you can see the video of this very interesting research. And the other one is the field study. I think most of you are familiar with candid camera, which they put people or participants in a situation in a real life without knowing that they have been set up. And the reason is that they want to see their natural and their normal reaction when you manipulate your independent variable. Again, there is another link here if you click on this that you can watch the video to see, although I think most of you have seen a lot of candid camera videos.